Back as we continue our study of some common functions that we need to be very familiar with to be successful in calculus, and also how to get a quick sketch, how to know the relationship between these functions. So here in the last video we looked at quadratic functions, or y equals x squared. Notice it's an even power of x. So it was an even function, right? That was an even function. Let's try and change the pen color. It's an even function. Remember, an even function, it is, you could reflect it around the y-axis. You get that symmetry. Now we got y equal x cubed, though. Notice we got a y equal x cubed. That's an odd power. You might suspect it has odd symmetry, and you'd be correct. Now, if we wanted to draw that here, we draw odd symmetry. It's going to start here, and then it's as it crosses 1, x cubed is going to grow faster. All right, if this is x cubed, notice if you put in like a 10, this would be 10, 100. But on the x cubed, it would be what? 10. 10 cubed is 1,000. So it should be above that. But now it's an odd symmetry. Remember what odd symmetry look like? It's going to look like that. Okay. So this is the function y equal x cubed. An odd function here. Well, how about the second one here? What happens if I put x minus 5? What does this minus 5 do to it? And again, that's going to translate it here to the right, because it's a minus 5. I might think about this. Where is this thing equal to 0? Okay. When I put in a 0 up here, it's equal to 0. Where's this equal to 0? At x equal to 5. So that's how I remember it's translated to the right by 5. So this is at 5. I know it's at 0. And now I'm going to try to shift all these things over by 5. Do my best with that. Okay. So this has to be going over by plus 5. Every point on this curve shifts to the right by plus 5. I've translated it by plus 5 there. What happens if I wanted to move this up? Again, if I wanted to move this up by, let's say, plus 2, what would I do? Well, if I wanted to move the whole curve up, then I could put a plus 2 over here. Okay, how about this, though? Now, this is, what is this? This is y2. Not to confuse you here. Let's get rid of the plus 2 business. I tend to do that a lot. I'll make sure. Okay. How about this third one? We'll go back to red. Now I notice, what does the negative sign do to things? Well, all that does is it now reflects everything down here. So let's see. This is going to now kind of come up like this. Okay, so this point now goes down here. This point that was here gets reflected up here. So this curve got reflected about the what axis? The x-axis. And this curve is what? y3. The next function you should be familiar with is what I would refer to as the reciprocal function. Let's look at this first one, y equal 1 over x. Here we can kind of use a concept as we're looking at 1 over x. What happens to this function as x gets closer and closer to 0 from the left side here? Let's draw it. See, if I come closer, if it gets closer and closer, as x gets closer, if I put in, let's make a little table, x, and then the function equal 1 over x. If x is like 1, well, it's equal to 1. What x is 0.01, then this is equal to what? 100. What if x is 0.0001? Well, then it's 10,000. So you can see what's happening as it gets closer to 0, this function is increasing. What happens as x gets bigger? As x gets to 10, this is 0.1. What happens as x goes to 100? It's 0.001, and so on. So the function looks like this. So we're going to talk about this in the next chapter, and this is but we can say the limit, as the function gets closer, closer and closer and closer to this, to x equal to 0 from the right side, the function blows up, gets very large, and we call this a vertical asymptote. As x gets very, very large out here, out to like 10 to the 14th, or infinity or something, this gets very, very small. Okay. Well, what happens on the negative side of things, though? What if this is negative 0.1? Well, then this is negative 10. What if it's negative? What if the x is negative 0.01? Well, if it's negative 0.01, then this is negative 100, and so on. So you might see as it gets closer and closer to this side, it's getting negative infinity. So it goes like this. And then the function actually goes like that. Is it an odd function? It sure is. It's an odd function. This is an odd function. I didn't draw this very well, but this, if I put in an x here or a minus x, I'd get the negative value. So this is an odd function. So this function in green is a reciprocal 1 over x, and you should be familiar with that. Now let's look what happens when we put 1 over x squared. Let me change the color. This is odd. This, though, is what? If you put in a negative x or a positive x, it's going to be the same. So this is even. Well, the trend here is kind of the same. See if you see this. As x goes, if I look at 1 over x squared, I'm talking about this, as x gets closer to 0, from the positive side, this is shooting up to infinity, only it's shooting up faster. You worry about that in BC calculus, not as much here, but here this is going to shoot up 0 faster, and actually it's going to get closer to 0 faster also. Okay, so this is 1 over x squared. But now when it's negative, remember it's an even function, so it's not down here. No, it's over here. It's even. I can reflect it. I can reflect it around that axis, and there's symmetry. So this is an even symmetric function. Okay, so these are reciprocal functions. It's very important that you understand those, 1 over x, 1 over x squared. In order to model vibrations or periodicity in a signal, which you find in a lot of physics problems, a lot of things in nature, a lot of sounds in particular, we use these trig functions, sines and cosines. So you really need to be familiar with those, again, in order to be successful in calculus. So here we got y equals sine of x. And you studied these before, and there's a lot to study on here, but we'll give you just some brief review. Remember, this is an odd function. It's odd. If it has a period here, this is what? This is pi. This is 2 pi. This is 1. This is negative 1. So this is sine of x. You should know the sine at the common angles, 30, 45, 60, and 90 degrees. Here's the sine. Well, what about the cosine? Let's change colors here. The cosine is an even function. It's even. I used it to describe that. It starts high, and again, it's going to be at negative 1 here, and then okay, it's even. So if I reflect it around here, I should get Okay, this is the cosine. Again, they both have periods of 2 pi, meaning they repeat. They repeat every 2 pi radians. When we're in calculus, we'll use radians. They have an amplitude of 1. So notice this thing has, if I ask for the range here, the range of these functions, both these ranges, f of x for both of these is less than or equal to -1, less than or equal to +1, greater than -1 for the range. Okay, I better stop here and start back in with my trig function. So again, trig function is very important. A lot you could review here again, but give me the basics. Can you sketch these? Do you know the period? Do you know what's going to happen in the next video? Do you know what happens if I do, like, say y3 is equal to 5 times the cosine x? What does that do? Well, it amplifies it. What happens if I put another function and I say the cosine of 2x? So anyway, I'll draw those in the next video. See you soon.